All right, so ready to go on a deep dive into clouds and the atmosphere. You've given us a ton of fascinating stuff to work with here, from like the water cycle to how we humans are impacting things up there. Should be fun.
Yeah, it always amazes me how much there is to learn about something we just, take for granted every day. The air we breathe, the clouds we see. It's a whole world up there.
Okay, so let's start with something fundamental, like you were saying, the water cycle. All our sources talk about this incredible journey water takes, evaporating, rising, forming clouds, and then boom, back to Earth as rain or snow or whatever. It's like a giant game of catch, but on a planetary scale.
Exactly. And the amazing thing is how crucial that game of catch is, right? I mean, without the water cycle, no fresh water, no drinking water, no agriculture, basically no life as we know it.
And speaking of what makes life possible, one of the sources actually shows the sun with a face on it, kind of like it's smiling down on us and, powering that whole evaporation process. Bit whimsical, maybe, but it makes the point that the sun's energy is the whole ball game here.
It's like the sun is the engine driving the whole system. And then as that water vapor rises, it gets colder, right? And bumps into all these tiny particles in the air, dust, pollen, even things like volcanic ash. These act as what are called condensation nuclei, basically giving the water droplets something to cling to, and that's how clouds are formed.
Hold on, volcanic ash. So you're telling me a cloud could be carrying tiny bits of a volcano from who knows how far away? It's
Right.
pretty wild when you think about it.
It is, and it just shows how interconnected everything is on this planet. These tiny particles, they can travel incredible distances, and they have a real impact on cloud formation, weather patterns.
Which is a perfect segue to talk about different types of clouds. Turns out not all clouds are created equal, right?
Mhm.
We've got our cumulus, stratus, cirrus, and nimbus clouds. At least that's what our sources are telling us. So what makes them so different? What gives them their unique shapes and personality, so to speak?
Well, it all comes down to altitude, temperature, and how the air masses are behaving, really. Take cumulus clouds, for instance. You know those puffy, cotton ball-like clouds?
Yeah, those are the happy ones, right?
That's a good way to put it. They usually mean good weather. They form at lower altitudes where the air is warmer and rising.
And then there are those flat, gray stratus clouds, the ones that usually mean rain is on the way. At least that's what it feels like.
You're not wrong. Stratus clouds, they form in stable air, often at lower altitudes too, and they can blanket the whole sky. And yeah, they're definitely associated with overcast conditions, drizzle, light rain, that sort of thing.
And what about fog? Is that just a stratus cloud that got lost and ended up at ground level?
You got it. Fog is basically a stratus cloud that forms when the air right near the ground cools down enough for the water vapor to condense.
So we've got our low-lying cumulus and stratus clouds, but what about those wispy cirrus clouds? Those are the ones that look like brush strokes across the sky.
Ah, cirrus clouds. Those are the high altitude artists of the atmosphere. They form way up high, above 16,500 feet, where it's much colder, and they're made of ice crystals, not water droplets.
And then there are the nimbus clouds, the ones that look like they mean business.
Exactly. Nimbus clouds are the heavy hitters. They're the ones that bring the rain, the snow, sometimes even hail. They form when there's a lot of uplift in the atmosphere, a lot of instability, and they can block out the sun completely.
Wow, so we've got our happy cumulus clouds, our gloomy stratus clouds, our artistic cirrus clouds, and our dramatic nimbus clouds. It's incredible how much variety there is in something as seemingly simple as a cloud. But let's shift gears a bit and talk about the bigger picture, the atmosphere itself.
All right, sounds good.
So one thing that surprised me going through these sources was learning that the atmosphere is mostly nitrogen, something like 78%. I always thought it was mostly oxygen.
Yeah, it's an easy mistake to make. We tend to focus on oxygen because, well, we need it to breathe, but nitrogen plays a crucial role too, even if it's less obvious.
Like what? What does nitrogen actually do?
Well, it helps regulate the Earth's temperature, for one, and it's important for plant growth. It's like the silent partner, maybe, in the atmosphere, making sure everything works the way it should.
Interesting. Our sources really emphasize just how essential the atmosphere is in general, not just for breathing, but for protecting us from harmful radiation from the sun, regulating temperature, and even acting as a sort of incinerator for meteors.
Absolutely. I mean, that thin layer of gas surrounding our planet, that's what makes Earth livable. Without it, we wouldn't stand a chance.
Okay, so we've established the atmosphere is basically Earth's best friend. It's looking out for us in more ways than we can count. But it's not just one big uniform thing, right? Our sources talk about different layers of the atmosphere, each with its own unique characteristics.
Yeah, that's right. Think of it like a layer cake, almost. each layer with its own specific ingredients and purpose.
So tell me more about these layers. What are they called and what makes them special?
Okay, well, the lowest layer, the one we live in, is called the troposphere. This is where most of Earth's weather happens, rain, snow, wind, all that. As you go higher in the troposphere, the air gets thinner and the temperature drops.
Which is why mountain climbers often encounter snow and ice even in the middle of summer.
Right. Right, exactly. It's like climbing a giant temperature ladder, and eventually you reach the top of the troposphere, and that's where you hit the stratosphere, and that's where things get really interesting, at least in terms of this deep dive.
Okay, the stratosphere, that's the one with the ozone layer, right? I have to admit, I'm a little fuzzy on what exactly the ozone layer does. I know it's important.
It is really important. Think of it like a giant sunscreen for the entire planet. The ozone layer, it absorbs most of the sun's ultraviolet radiation, the stuff that can cause sunburn and skin cancer, and it can damage plants too.
So without the ozone layer, we'd be toast.
Pretty much. Life would have to either stay in the oceans or underground. Not a good situation.
No, not at all. So we've got the troposphere, the stratosphere. What's next in our atmospheric layer cake?
Above the stratosphere is the mesosphere, and it's often overlooked, but it's pretty amazing in its own right. This layer, it's where the temperature gets the coldest in the whole atmosphere, and it's also where most meteors burn up.
Wait, so when I see a shooting star, what I'm actually seeing is a meteor burning up in the mesosphere. That's kind of beautiful and terrifying at the same time.
It is. It's a good reminder that we've got this built-in protection system up there, keeping us safe from all that space debris. But anyway, going up even higher, we get to the thermosphere.
The thermosphere.
Yeah, and this one's interesting because the air is incredibly thin, but the temperature is really high, thousands of degrees.
How could it be that hot if the air is so thin? Would you even feel it?
Yeah, it's not really heat you can feel, not in the way we normally think of it. The molecules are moving really fast, but there are so few of them it wouldn't actually feel hot to us. Anyway, there's a region within the thermosphere called the ionosphere, and this is important because it plays a big role in radio communication.
Okay, I think I remember learning about that in school. Something about ions reflecting radio waves.
Exactly. Basically, the sun's energy, it ionizes the air molecules in the ionosphere, and that creates these electrically charged atoms that can reflect radio waves back to Earth.
So that's how we can listen to radio stations from all over the world, thanks to this layer of electrically charged particles way up in the atmosphere.
Yep, it's part of it. And then finally, we reach the outermost layer of the atmosphere, the exosphere, and this is where the atmosphere gradually merges with space.
So the exosphere, that's like the final frontier of our atmosphere.
Pretty much. It's wild when you think about how much is going on in this relatively thin layer of gas that surrounds our planet. It's protecting us, it's regulating the climate, it's allowing us to communicate across continents.
Okay, so we've talked about how amazing the atmosphere is, how important it is, but we also have to address the elephant in the room here, which is climate change, right? These sources don't shy away from that.
Yeah, unfortunately not. And, it's one thing to read about it, hear about it in the news, but diving into the specifics, looking at the data, it's really sobering.
Yeah, absolutely. So what are some of the key takeaways from these sources about how human activities are impacting the atmosphere? What's standing out to you?
Well, one thing that really struck me was how these sources connect the dots between what we do every day and the quality of the air we breathe. It's not just about factories and power plants, it's about the cars we drive, even the products we buy. Everything has a footprint.
It's true. We often don't make those connections in our daily lives.
Right. And one of the big issues, of course, is air pollution. Our sources really emphasize that air pollution isn't just some abstract concept, it's directly impacting our health.
It's easy to forget that breathing is something we just do automatically, but the quality of the air we're breathing, that has huge implications for our health.
Exactly. And not just our physical health, but also the health of ecosystems, agriculture. It's all interconnected.
So we've covered a lot of ground here. And it can feel a bit overwhelming, honestly, all this talk about climate change and pollution and everything. Do these sources offer any hope? Are there things we can do, or is it, too late?
Yeah, it's a big question, no doubt. I mean, these sources definitely don't sugarcoat the challenges, but they do point to some positive developments, some reasons for cautious optimism, maybe.
Okay, I could use some good news right now. What are you seeing?
Well, remember we were talking about the ozone layer and how important it is? The Montreal Protocol, that was a global agreement, back in the 80s actually, that phased out a lot of the substances that were damaging the ozone layer.
Yeah, vaguely.
Right, but the point is, it worked. The ozone layer is actually recovering. It's a good example of how, when countries get together, take action, we can actually solve these global environmental problems.
Okay, so there's precedent for tackling these big environmental threats. That's good to hear. What about things like climate change and air pollution? Any success stories there, or are we still waiting for those?
Well, we're seeing a big push for clean energy, right? Solar, wind, geothermal, and the technology is improving all the time, which is key.
Yeah, I've definitely noticed that. It seems like everyone's putting solar panels on their roofs these days, which is great.
Yeah, it's encouraging. And then electric cars, public transportation, those are becoming more common too. So there's definitely movement in the right direction.
So it sounds like a combination of individual choices, better technology, and really some big policy changes are all going to be necessary to address these challenges effectively.
Exactly. It's a multi-pronged approach, for sure. No easy answers.
Well, this deep dive has been quite a journey. We've explored how incredible the atmosphere is, how it works, why it's important. We've also talked about some pretty serious threats.
It's a good reminder, I think, that we're not separate from nature. What we do, it has an impact.
Absolutely. It makes you look at the sky, at a simple cloud in a whole new way.
It's pretty amazing when you stop and think about it.
It really is. Well, we've reached the end of another deep dive. Thanks for exploring the world of clouds and the atmosphere with us. Till next time.